Yeah, welcome back to the lecture of biological wastewater treatment. Today we will talk about concepts of the biological wastewater treatment with the activated sludge process. Also now you have learned what type of metabolisms are important for wastewater treatment, and you also know what environmental conditions, even anoxic, anaerobic or aerobic, if there are some special requirements for substrates and so on, everything you should know. And now is the question to remove nitrogen, phosphorus and COD, how we can set up a wastewater treatment plant. Yeah, and then we will have a look what dimensions the reactors has to have. Okay, I will also go away and talk about this. Normally, we are developing in discussion inside the class nice concepts. But this is not possible this year because we have to do an online lecture, and therefore I suppose what normally comes out. As many people are remembering, we need an anaerobic tank in the beginning, which is quite useful to make a growth advantage for phosphate storing bacteria. Also we want to perform biological phosphorus removal. Yeah, then we have in the water COD and ammonia, and to undergo this treatment we need a step for the C degradation and nitrification. Yes, and then we are producing a lot of nitrate. This has to be removed. And therefore we are putting the denitrification step in between, and of course a secondary clarifier in the end to separate the sludge. A big part of the sludge will be recycled to increase the sludge concentration, but finally we have to remove as well excess sludge so that we have a clear effluent. But this approach has some very unpleasant disadvantages, and this is mainly in the fact of the denitrification. Finally, we don't need to aerate the step, but there is the biodegradable COD or C missing. Hopefully in this step where nitrifying bacteria can live, we can be quite sure that at well mainly all biodegradable COD is already removed, and therefore we only have storage products or endogenous products. We can make so-called endogenous denitrification, but this is very, very slow. Therefore the normal way is that we need to inject an external C source like methanol, and this would improve the process, but normally this is not really wanted, because we have to pay for it. This is quite expensive, it's energy waste, and on the other hand the wastewater brings a lot of C sources with itself, and therefore the idea is how to set this up to make use of the C source in the wastewater. There is implemented the so-called Foredox process. This was also the process where the first biological phosphorus removing wastewater treatment plant in Germany was operating in Berlin-Ruhling. We have as well this anaerobic tank beforehand, and after the anaerobic tank the water goes to the denitrifying reactor. There is no nitrate yet, but finally after this tank there is a step C degradation and nitrification, and from this tank we have to recycle water backwards, because here nitrate is produced, and so if we bring this back we can denitrify this. Last not least, in the secondary clarifier the sludge is separated, excess sludge is also removed, and a big amount is brought back to the anaerobic sketch. This sounds quite nice. So we can make use of the internal C sources, what is not stored in the BWP bacteria, but we can only degrade with respect to the recirculation degree. Also we have two recirculations, the return sludge and the internal recirculation due to denitrification. And we can imagine if we have 100% denitrification, in this case, then we maybe have 80% if we have a big recirculation rate. Also therefore this is limited due to this aspect. This is one small disadvantage, but finally this is done nearly always in German wastewater treatment plants with nutrient removal. The other disadvantage is that, of course, with the return sludge we are bringing back also nitrate. And nitrate in the anaerobic tank is also not of advantage because finally the bacteria would use first the nitrate and can grow. That is the normal heterotrophic bacteria and the BWP bacteria that are storing easily biodegradable COD in form of polybeta butyrate or other storing products with the release of phosphate have less substrate. Therefore the idea goes ahead what to do. Yes, finally the idea is to make a denitrification beforehand, the modified redox process. Also finally the return sludge is also denitrified in an extra basin using this sea sources of the influent. This is also a good idea, but there is also a disadvantage inside. Finally the denitrifiers are already removing easily biodegradable components. And this first stuff, the fatty acids, also finally the stakes for the bacteria are already reduced when the water comes to the anaerobic reactor. Therefore I think this is not done. The redox process, this is often done. There is enough basins available, and so if you redirect the recirculation a little bit later and have an anoxic zone beforehand, this is easy to implement. And finally, if you need more place for denitrification, you can skip the anaerobic part easily and adding some flocculants. Yes, but there are other interesting approaches in the literature, mainly known as UCT process. UCT stands for the University of Cape Town, but in the German literature, the University of Hanover, they also reclaiming for this. This is the Institute of Siedlungswasserwirtschaft and Abfallwirtschaft Hannover. But finally, international, and here it's known as the UCT process. They are doing mainly the same, but they are making the denitrification of the return sludge after the anaerobic selector. They have also two returns. Also they have internal recirculation for the denitrification, and then they make a return sludge denitrification, and this goes back to the anaerobic part. Mainly all new built or specially designed wastewater treatment plants with biological pre-removal in Germany are operating within this scheme. Only if there is another wastewater treatment plant already running and they say, okay, we want to try some BOP, then they are putting this redox process in action. Also, therefore, this is quite helpful. This is the wastewater treatment plant in Hildesheim and so on, also near Hanover. This is important. Hamburg don't have this biological pee removal. There are some other interesting processes. Also one thing is that the anaerobic part often lacks in easily biodegradable organic components, and there the idea came in action to use the primary clarifier as well. Also finally to mix the return sludge with the primary clarifier as well. Then you have in the settled sludge also some biodegradation. You can imagine like an Imhoff tank or something like that, some fermentation, and there are some fatty acids are produced and they brought back to the anaerobic basin. And then they have ideal conditions, a lot of easily biodegradable COD and so on. Finally, this is a good idea, but seldom done, too complicated. Finally, we need more aeration energy because the sludge is also go to the reactors. And finally, we want to gain, also in Germany, this is at least the case, as much sludge as possible to produce biogas. And therefore, this is not done. Also because also it's quite easy to precipitate the material. There are other interesting processes on the market developed in the United States, the so-called full-strip process. The idea is to run a normal wastewater activated sludge process with pre-connected denitrification, but from the return sludge you're taking a part off and storing this in the so-called P-stripper. The P-stripper is the anaerobic basin, where finally the due to fermentation easily biodegradable organic material is produced, and bacteria that are able to store this are preferred. And they are also phase separated. The sludge, which is going backwards to the influent, also to the denitrification tank, but the supernatant, where the phosphates are in higher concentration, because in the anaerobic basin the microorganisms are using polyphosphates, and due to the hydrolysis of polyphosphates to phosphate, they are gaining the energy to store this fatty acids in form of polymers inside their cell. And finally, in this partial flow, the P can be precipitated, for example, with lime to produce the P sludge that can be directly go to the fertilizer industry. To precipitate apatite or calcium phosphates, you have to rise the pH to the level of 10.5, and this you will not do in the full stream. Therefore, the side stream approach is more or less a quite nice idea. In Germany, there were realized 2 plants with this scheme, but finally they are resulting in problems with bulking filamental sludge, and so, as I know, they are switched off. Sometimes this process is used for other sludges from sludge digestion to produce easily from the supernatant P sludge apatite, which was working quite economical because the P prices sometimes are high, and so they can win some P. But finally this process has no future, because finally in 10 years, I think from 2034 on, the phosphate has to be recycled. Also finally the wastewater treatment plant has to remove more than 80% P, I think 90%, and bring it as a recirculate backwards. And finally this is not possible with this process, and therefore I don't see a big future. But finally we have also many small wastewater treatment plants also in the countryside, and they don't have many basins. They have one big tank with a very long hydraulic retention time and also a big sludge retention time. Sometimes they also don't have primary sedimentation. They only had grit chamber and screenings and so on beforehand. to remove everything that comes to the wastewater treatment plant. And then they also save energy, and they make an intermittent aeration. They sometimes aerate, sometimes not. Yeah, mainly they are aerating only to keep the sludge in motion and is not sedimented. And in these plants, they observed as well a very good degradation of nitrogen and as well of P. Also therefore this is here also done. We have in smaller plants as well the so-called carousel process or oxidation ditch. This is in basin in this form, which is separated in two parts, and the water passes recirculated. And originally the oxygen is transferred with surface aerators that bring the water in motion. And so before the water leaves the process, 10 or 20 times has recirculated in the middle. Yeah, nowadays the surface aerators are a little bit out of the mode because they need more energy for the transferation of 1 kilogram oxygen. And therefore normally now there are membrane aerators installed and steerers that makes the motion of the water. But finally this is also a good process, which also a very good removal of nitrogen. Yeah, then we have other ideas. You can separate the processes. Also you can make a denitrifying wastewater treatment plant and make a post-nitrification, for example, with an activated sludge process. But in any case, in this case, you need as well to add methanol. Also you will not do this in this form. Also you will use high performance reactors for this, for the denitrification. This is normally done if you don't have space to expand your wastewater treatment plant for a complete nitrogen removal. Also this is done, for example, in Frankfurt. And they have installed some fixed bed reactors, biofilters with methanol doses for denitrification with a lot of control options. And this is a very small plant that brings the nitrate N to nearly zero. And therefore they only make one partial flow of the wastewater treatment plant to fulfill the requirements. But in any case you need methanol or other sea sources. Yeah, finally there are other plants. If you have a pre-connected denitrification, as we had learned here before, there is not 100% removal of nitrate, maybe 80%. And sometimes if you want to remove everything because you have a very sensitive receiving water or special requirements, then you can make a post-denitrification, but you need an external carbon source. In former times there was always an aeration tank afterwards. This was done for security reasons. Nowadays this is not necessary because the nitrate probes and the control systems are so good that the dosage of the sea sources could be controlled very good. But finally it's nice to fresh the water with some oxygen and not bring it as oxygen-free water to a receiving water body. Yeah, two sludge systems. This is also interesting because we are dealing with two very different types of microorganisms. We have the heterotrophic microorganism that are doing the BOP, the denitrification and the sea removal, and we have the nitrifying, the autotrophic microorganisms that are growing a lot. The growth rates are a lot smaller, factor 10 or something like this. And so we have to remove sludge because if not, we have it in the effluent. And in this case, if we are separating these bacteria, we can achieve in the nitrifying basin a higher concentration of autotrophic microorganisms. And of course, we have to bring back the nitrate from the nitrification plant. Also it sounds a good idea, but there is a bottleneck, therefore this is not done in this form. Now, the problem is that you indeed save a lot of space for the nitrification step. This is a good thing. But the hydraulic load of the secondary clarifier, finally the last step of the wastewater treatment plant, is really high, because all the hydraulic load of the internal recirculation is also operated through this secondary clarifier. And so what you are saving for reactor volume for the nitrification, you have to spend more for the secondary clarifier, and therefore nobody is doing this. No? But finally it's a good thing to separate these microorganisms. We will see in this case there we have a biofilm reactor for nitrifying bacteria, for example trickling filters. And here the idea is that we have a high load wastewater treatment plant for heterotrophic bacteria. There we can remove also a lot of oxygen, of phosphate, because we can remove more sludge, but we are not doing this. We are removing this excess sludge to the denitrification step as well for producing, also for denitrification. In many cases there we need to add as well external carbon sources. And then we have the secondary clarifier. This works also quite nice. It could be also your thought that you bring one part back to the denitrification step, what is not indicated here, but I always would do so. But there are many ideas how you can combine different reactors, and there your fantasy is free. Also there are many other steps like cascade denitrification or what else. There you can think, maybe you can suggest other schemes of treatment. I would be happy if you send me an email and make a suggestion. Okay, thanks you very much.